Good afternoon to everyone. Welcome to the another session on Engineering Mathematics 4. And today we will discuss about application problems. They are using Fourier sine and cosine transforms. Fourier sine and cosine transform, as well as finite Fourier sine and finite Fourier cosine transforms. Initial and boundary value problems here. Initial and boundary value problems. That thing is present here. Using Fourier sine and cosine transform. Fourier sine and cosine transform, that type of idea, we can see that. And also we'll see further classes transverse vibration of stretched elastic string. That we'll see further. Solving boundary value problems, application of Fourier transform. Put the heading as application of Fourier transform. Solving boundary value problems. Solving boundary value problems. Solving boundary value problems. For dimensional heat equation. Solution of one-dimensional heat equation. Solution of one-dimensional heat equation. In this section, we will solve the one-dimensional heat flow equation. In this section, we will solve the one-dimensional heat flow equation. Dou U by dou T is equal to alpha square and dou square U by dou X square. In this section, we will solve the one-dimensional heat flow equation. Dou U by dou T is equal to alpha square into dou square U by dou X square. To solve the solution of this equation Ux comma T. Solution of this equation Ux comma T. Solution of this equation Ux comma T gives the temperature distribution of the heat flow. Gives the temperature distribution of the heat flow. Temperature distribution of the heat flow at the distance x. At the distance x. And at the time t. And at the time t. The solution of the equation is Ux comma T. X represent distance of the bar. Initial point is x equal to 0. And the different points as measured here. Distance of the bar where you are going to measure temperature, and T at the time where you are going to measure the temperature. For at the distance x and at the time t. Here alpha square is called diffusivity of the substance. Here alpha square is called diffusivity of the substance. Here alpha square is called diffusivity of the substance. So this is your metal bar here. Suppose it is a finite length x equal to 0 to x equal to L. Temperature, we are heating the metal bar from one end. And then it flows through the metal bar. And after some time, we are going to measure the temperature at each and every point of the bar here at different point x and at a different time t, different time t. Here, why it is called one-dimensional heat flow equation means here inside the metal bar, the temperature moves like a straight line form. The temperature moves like a straight line form, and that's why it's called one-dimensional heat equation. One-dimensional heat equation. That type of idea we can get that. Or it moves like a straight line form. Here, heat flows from higher to a lower temperature. Here, heat flows from higher to a lower temperature. And moves like a straight line way. And moves like a straight line way. And moves like a straight line way. Here, heat flows from a higher to lower temperature and moves like a straight line. Stop. The above PDE, dou u by dou t is equal to alpha square into dou square u by dou x square. The above PDE, dou u by dou t is equal to alpha square into dou square u by dou x square is also known as heat conduction of a bath. It's also known as heat conduction of a bath. Is also known as heat conduction of a bath. To solve this PDE, we require the following results. We require the following results. Here you no need of this definition. You write FC because we are going to use Fourier sine and cosine transform. Therefore, no need of this results here. To start from this one. This is 1. This is result number 1 and 2. And no need of this one is also. These 4 results is enough. This is result number 1 and then 2. This is result number 3 and then 4. Result number 3 and 4. Write that first one, FC of dou square u by dou x square, because the equation contains dou square u by dou x square. This is dou u by dou t here. Therefore, FC of dou square u by dou x square, if you apply Fourier cosine transform, then on dou square u by dou x square, you are getting the result as minus s square FC of u, minus root of 2 pi pi, dou by dou x of u of 0 comma t, minus root of 2 pi dou by dou x of u of 0 comma t. Similarly, second result, Fourier sine transform of dou square u by dou x square. Fourier sine transform of dou square u by dou x square equal to minus s square fs of u plus root of 2 pi pi s into u of 0 comma t, s into u of 0 comma t, s into u of 0 comma t. This is by the results of Fourier sine and cosine transform, infinite Fourier sine and cosine transform ideas. Under Fourier sine transform and Fourier cosine transform. That is obviously infinite Fourier sine and infinite Fourier cosine transform. Similarly, the left side part, FC of dou u by dou t, this part here. FC of dou u by dou t, because Fourier sine or cosine transform means you are going to integrate with respect to x here. Is u of x comma t here. Therefore, you take t outside here, dou by dou t outside of integration, then it will be d by dt. D by dt, yeah, fc of u Fourier cosine transform u fc of u fc of, and fs of, similarly fs of dou u by dou t is equal to fs of dou u by dou t equal to d by dt fs of d by dt fs of, right. One thing you can understand here, here cosine transform, if you consider cosine transform dou by dou x of u of 0 comma t, if you consider sine transform, you can get u of 0 comma t here, u of 0 comma t. For u of 0 u of x comma t means temperature distribution throughout the bar. U of 0 comma t means at the initial point x equal to 0, the temperature distribution is given. You have to adopt Fourier sine transform. Similarly, at the initial point x equal to 0, temperature gradient dou by dou x means temperature gradient. Temperature gradient is given. You have to adopt Fourier cosine transform. Okay, Fourier cosine. This is the only distinction you can get. This is common idea only. This is common. Whenever temperature is given, you have to apply Fourier sine transform. Whenever temperature gradient is given at initial point, you have to apply Fourier cosine transform. Okay, right. Note, write a note here. Note. In the problems, suppose we have u of 0 comma t. We have u of 0 comma t. The problems we have u of 0 comma t. We have to apply Fourier sine transform. We have to apply Fourier sine transform. And if we have dou by dou x of u of 0 comma t, dou by dou x of u of 0 comma t, dou by dou x of u of 0 comma t, this temperature gradient, that is temperature gradient at x equal to 0. Temperature gradient at x equal to 0. Now you have to apply Fourier cosine transform. You have to apply Fourier cosine transform. So this is the idea you have to remember. This is the idea you have to. Yes, problem number 1. Problem number 1. Solve dou u by dou t is equal to dou square u by dou x square. Dou u by dou t is equal to dou square u by dou x square. For x greater than 0, t greater than 0, given that u of 0 comma t equal to 0, u of 0 comma t equal to 0, for 1. Number 2, u of x comma 0, u of x comma 0 equal to 1 for 0 less than x less than 1, for 0 less than x less than 1, and 0 for x greater than or equal to 1. 0 for x greater than or equal to 1. Number 3, u of x comma t is bounded. U of x comma t is bounded. X comma t is bounded. Sure. Yes. You see that this is the one-dimensional heat equation. Already you know that here. Here x greater than 0, 0 to infinity. Therefore, you have to apply Fourier sine cosine transform or cosine transform. Depends on the condition. Given u of 0 comma t equal to 0. U of 0 comma t is given. U of 0 comma t is given. Therefore, you have to adopt Fourier sine transform. Fourier sine transform. It means infinite Fourier sine transform on this equation. Further, you have initial condition. This is general condition only. General u of x comma t is bounded means it is a temperature. Temperature means it is a bounded value only. A bounded value. Therefore, they have given that type of condition. But for this is not at all important, but these two are important conditions. Yeah, this condition is given, you have to adopt Fourier sine transform. Okay, right. Solution right there. Solution given dou u by dou t is equal to dou square u by dou x square. Given dou u by dou t is equal to dou square u by dou x square. 0 less than x less than infinity. T greater than 0. T greater than 0. Also given u of 0 comma t is equal to 0. U of 0 comma t equal to 0. Therefore, apply Fourier sine transform on 1. Apply Fourier sine transform on 1. Because of u of 0 comma t is equal to 0 is given, therefore you have to apply Fourier sine transform on 1. For fs of dou u by dou t, fs of dou u by dou t is equal to fs of dou square u by dou x square. Fs of dou square u by delta. Fs of dou u by dou t means that's equal to d by dt of fs of u. D by dt of fs of u. Already you know that. This is your take dou by dou t outside of integration d by dt of Fourier sine transform of u. And then for this one, you take first result here. Fourier sine transform of dou square u by dou x square. I think second result, Fourier sine transform of second result. Fourier sine transform of dou square u by dou x square equal to minus s square fs of u plus root of 2 pi by s0 u of 0 comma t. And these two are same, but here minus, here plus. Here s, but here dou by dou x. S u of 0 comma t. Minus s square fs of u minus s square fs of u plus root of 2 pi pi s into u of 0 comma root of 2 pi by s into u of 0 comma t. U of 0 comma t. But already given u of 0 comma t equal to 0. Right. And also assume that fs of u as a s bar, u bar, fs of u as a u bar. Let fs of u is equal to u bar, fs of u is equal to u bar, and apply u of 0 comma t is equal to 0, and apply u of 0 comma t is equal to 0. U of 0 comma t is equal to 0. We take fs of u as a u bar, therefore it will be u bar, and here fs of u as a u bar minus s square u bar, d by dt of u bar is 0. And u of 0 comma t is given as 0. U of 0 comma t equal to 0. Okay, right. U of 0 comma t means at the initial point the temperature is 0. Now it is like a differential equation, ODE, ordinary differential equation. Therefore, du bar by dt equal to minus s square u bar. Du bar by dt is equal to minus s square u bar. Apply variables as separable idea. Du bar by u bar. We take u bar here and dt here minus s square dt. Variables are separable idea. Then log u bar equal to minus s square t. Log u bar equal to minus s square t plus c. Plus u bar equal to take exponential e power minus s square t e power c. E power minus s square t e power c. But u bar, what is u bar? U bar is Fourier sine transform u. Fourier sine transform u. As u bar equal to Fourier sine transform u is what here in terms of variable x and t, displacement, distance and the temperature, time. not temperature T, the time, distance and time. First one. So after taking Fourier transform for this function, this x comes as a S form here, transformation. T as it is only here. Therefore, it comes as a U bar S comma T, U bar of S comma T. For this U bar, generally written as U bar S comma T, U bar S comma T. I will take this e power c as a e power minus s square t, a e power minus s square. Therefore, U bar means its variables are S and T. Okay? S and now you have to identify A idea, A value here. To find A, next one. We have the another initial condition here. U of x comma 0 equal to 1 or 0 to 1 or greater than 1, 0. We have the another initial condition, another initial boundary condition. We have the another boundary condition. U of x comma 0 equal to 1 for 0 less than x less than 1, 0 less than x less than 1, 0 x greater than or equal to 1. Now apply same transform on this boundary condition also. Apply same transform on this boundary condition also. Apply Fourier sine transform on the above function. Apply Fourier sine. We initially apply Fourier sine transform. Therefore, here is also apply Fourier sine. Apply Fourier sine transform. Apply Fourier sine transform on the above function. Function is u of x comma 0. Okay. For Fourier sine transform take. Then Fourier sine transform u of x comma 0. Fourier sine transform u of x comma 0 equal to root of 2 pi pi. Because it is infinite Fourier sine transform. So interval 0 to infinity, root of 2 pi into 0 to infinity. Instead of f of x, here u of x comma 0 sin sx dx. U of x comma 0 sin sx dx. Root of 2 pi pi. Root of 2 pi pi. 0 to 1, 1 to infinity. That one I can split here. Therefore, 0 to 1 plus 1 to infinity. U of x comma 0 sin sx dx. It is Fourier sine transform here. Then after that, after Fourier sine transform, you are going to represent by u bar and x transformed into s form here. Therefore, s comma 0. That's no t is 0. Therefore, u bar s comma 0. So root of 2 pi pi. Equal 0 to 1. 0 to 1, it is 1. It is defined as 1. 0 to 1, it is defined as a 1. 1 sin sx dx. For other end, all 0. 0. Root of 2 pi pi 0 to 1 sin sx dx. For root of 2 pi pi, sin sx integration is minus cos x by s 0 to 1. So for root of 2 pi pi, I will take minus 1 by s outside. It will be cos s, cos 0 1. Instead of x 1, instead of x 0. So cos s minus cos 0 1. Okay? This is your answer for u bar s comma 0. U bar s comma 0 equal to root of 2 pi pi 1 by s, 1 minus cos s by s. So u bar of s comma 0 equal to u bar of s comma 0 equal to root of 2 pi pi 1 minus cos s by s. 1 minus cos s by s. This is u bar s comma 0. But already we identified that u bar s comma t. This is equation 2. For this a only we are using that transform here. Already by 2, u bar s comma t is equal to a e power minus s square t. A e power minus s square t. Put t is equal to 0. For u bar of s comma 0 equal to a. U bar of s comma 0 equal to. From comparing these, we have here t equal to 0. A. It is also u bar s comma 0. Now it is also u bar s comma 0. So comparing these two, you can get a equal to root of 2 pi pi 1 minus cos s by s. A equal to root of 2 pi pi 1 minus cos s by. So once again substitute a here, obtained result u bar s comma t is equal to a e power minus s square t. Therefore equation 2 implies u bar s comma t is equal to a e power minus s square t. U bar s comma t is equal to root of 2 pi pi 1 minus cos s by s into e power minus s square. Root of 2 pi pi 1 minus cos s by s e power minus s square. Yes, this is u bar s comma t. U bar s comma t means what? You replace a by root of 2 pi by 1 minus cos s by s here. U bar s comma t means Fourier sine transform of u x comma t. This is nothing but Fourier sine transform of u of x comma t. Okay, right. But we are interested to find u of x comma t. U of x comma t only gives the temperature distribution of the bar. U of x comma t only gives temperature distribution of the bar. So from this, if you want to identify u of x comma t, what you have to do here further?
Inverse Fourier
Inverse
transform.
Fourier transform.
Okay, inverse. Now you have to take inverse Fourier sine transform. Inverse Fourier from this. So now apply inverse Fourier sine transform. Apply inverse Fourier sine transform. We have u of x comma t. U of x comma t is equal to root of 2 pi pi. Instead of f of x, u of x comma t, root of 2 pi pi. Its Fourier transform is u bar s comma t. Its Fourier transform is u bar s comma t. Root of 2 pi pi 0 to infinity u bar s comma t sin s x ds. U bar s comma t sin s x ds. But u bar s comma t is already you have root of 2 pi pi 1 minus cos s by s e power minus s square t. So substitute here root of 2 pi pi 1 minus cos s by s e power minus s square t. This is u bar of s comma t into sin s x ds. Right. Root of 2 pi pi 2 pi pi you take it outside here. Therefore u of x comma t. U of x comma t is equal to 2 pi pi 0 to infinity 1 minus cos s by s sin s x e power minus s square t ds. You have to integrate with respect to s only. You have to integrate with respect to s only. Therefore, this is the general solution here. If you know particular values of the distance of the bar where you are going to measure the temperature and the time at the time you are going to measure the temperature. If you know particular values of x and t, you substitute here x here and t here, particular values here. Now everything comes in terms of s. Everything comes in terms of s. Then you can integrate further. Yeah. So this will be, but you don't know what will be the exact x and t value. Therefore, we can leave this problem as it is. This is a general solution only here. U of x comma t is equal to 2 pi pi integral 0 to infinity. You no need to solve the integration. If you know particular values only, you can solve the integration. Therefore, leave as it is. 1 minus cos s by s sin s x e power minus s square t. After taking inverse Fourier sine transform, we can start the process. Again, start the. This will be your okay, right. The idea is very simple. You have to apply Fourier sine or cosine transform on this equation depends on the initial condition. Here u of 0 comma t is given, therefore you have to apply Fourier sine transform. After applying that, substitute the respective relations. Respective relations, you know that. And then apply initial condition also, u of 0 comma t is equal to 0. We can get a differential equation. We're going to take the fs of u as a u bar. U bar means u bar of s comma t. U means u of x comma t. Therefore, Fourier transform means u bar of s comma t. To solve that, you can get u bar of s comma t in terms of unknown constant a and a t. Now to identify a, for that you have to use another initial condition, this second one here. This is general idea only, therefore no need to think about u of x comma t. It's general idea, u of x comma 0 is equal to so on. With the help of this, you can find, with the help of second substitution, can get a value. So you can use same transform. You can apply same transform for this function also. You can get u bar of s comma 0, u bar of s comma 0. But already you have u bar of s comma t, substitute t is equal to 0, you can get a. Therefore, you can compare these two, you can write a value. Now you can generally write there what is u bar of s comma t. U bar of s comma t means Fourier sine transform u of x comma t. Then you want to find u of x comma t means you have to take inverse, that's all. Then the problem is over. This is the idea we can follow. All of you, I think all of you understand the idea. The same manner you take another problem here. I think we can also easily get the answer. Right, the second one. Solve dou u by dou t. Dou u by dou t is equal to a square into dou square u by dou x square. Solve dou u by dou t is equal to a square into dou square u by dou x square. For 0 less than x less than infinity, t greater than 0. U of x comma 0 is equal to e power minus ax. U of x comma 0 equal to e power minus ax. First one. Second one, dou by dou x of u of 0 comma t is equal to 0. Dou by dou x of u of 0 comma t is equal to 0. T greater than 0. Third one, u of x comma t is bounded. U of x comma t is bounded. Third one, u of x comma t is bounded. A solution. You see the given problem. First one and the third or second subdivision, u of dou by dou x of u of 0 comma t equal to 0 is given here. Then what type of transform you have to apply? Fourier sine or cosine transform?
Cosine.
Cosine transform. Very good. To be cosine transform you have to. Because dou by dou x temperature gradient at the initial point is given. For cosine transform you have to apply. Or given dou u by dou t equal to a square into square u by a square. It's not alpha square, a square into dou square u by dou x square. 1. Since dou by dou x of u of 0 comma t equal to 0 is given, dou by dou x of u of 0 comma t equal to 0 is given, apply Fourier cosine transform on equation number 1. Apply Fourier cosine transform on equation number 1. Or apply Fourier cosine transform, fc of dou u by dou t left side. Right side, a square into fc of a square into fc of dou square u by dou x square. A square into fc of dou square u by dou x square. And this will be d by dt of fc of u. D by dt of fc of u. That is equal to a square into Fourier cosine transform of dou square u by dou x square. You know already the result. Minus s square fc of u by first result. Minus s square fc of u minus root of 2 pi by dou by dou x of u of 0 comma t. Minus root of 2 pi by dou by dou x of u of 0 comma t. Hello? Yes, okay. It is left side is dou by dou t. We can take it as d by dt d by dt FCF. Take it outside of integration, d by dt FCF. This result already you know that, and the first result here we can substitute. But this part is given as 0. So now apply dou by dou x u bar 0 comma t equals 0. This is 0. And assume that FC of u equal to u bar. Here is also FC of u and here is also FC of u. Fourier cosine transform is u bar of s comma. U bar means u bar of s comma t. So d by dt of u bar is equal to a square minus s square u bar minus 0. Du bar by dt equal to minus s square a square u bar. Du bar by dt is equal to minus s square a square u bar. It's already 0. Now you can use variables as separable idea. Du bar by u bar equal to minus s square a square dt. As usual, like a previous problem. Remaining things you can easily proceed yourself. Now integrate this one. You can get log u bar equal to minus s square a square t plus c. Log u bar equal to minus s square a square t plus c. That's equal to u bar take exponential here e power minus s square a square t and e power c. U bar equal to u bar s comma t bar s comma t. That's equal to a e power minus s square a square. A e power minus s square a square. I'll take e power c as a e power minus a square. Okay. So this u bar is nothing but u bar s comma t. This is the second equation. Now you have to identify the value of a. For that, what you have to use here, you take another initial condition u x comma 0. Therefore, that you can find the value of. To find a, I have the boundary condition u x comma 0 equal to e power minus ax. U x comma 0 is equal to e power minus ax. Apply Fourier cosine transform because I started with the Fourier cosine transform. The Fourier is also out start Fourier cosine transform. Apply Fourier cosine transform on the above function. And take Fourier cosine transform. Fourier cosine transform u x comma 0 equal to root of 2 pi pi 0 to infinity 0 to infinity u x comma 0 cos s t. Right. But Fourier cosine transform of u is u bar. After transformation, you can get s x in terms of transformed as s form here. For u bar s comma 0, result is in terms of s comma 0 form. Root of 2 pi pi 0 to infinity u x comma 0 equal to e power minus ax cos sx dx. Cos sx. Root of 2 pi pi e power in the formula is e power minus ax by a square plus b square, a square plus s square minus a cos sx. Because my a is minus a cos sx plus b sin bx, s sin sx 0 to 0 to infinity. So e power minus infinity 0, e power minus infinity 0 and then it will be e power 0 1 by s square plus a square cos 0 1 sin 0 substitute 0 will be cos 0 1 minus a, you can get here minus a, and sin 0 0 minus a. For u bar s comma 0 equal to root of 2 pi by a by s square plus a square. Root of 2 pi by a by s square plus a square. But by equation number 2, we have already, you know, this is u bar s comma 0 obtained result, but already you have the result u bar s comma t is equal to a e power minus s square a square t. A e power minus s square a square t. Equation number 2 is here, u bar s comma t a e power minus s square a square. U bar s comma 0 is equal to a. I put t is equal to 0 here. U bar s comma 0 equal to a. It is also u bar s comma 0. This also u bar s comma 0 or a. Both are a. Or a equal to root of 2 pi by a by s square plus a square. A equal to root of 2 pi by a by s square plus a square. Hence u bar s comma t is equal to u bar s comma t is equal to a e power minus s square a square t. A e power minus s square a square t, that comes as a is now root of 2 pi by a by s square plus a square e power minus s square a square t power minus s square a square t. This is u bar s comma t. Generally, this is Fourier cosine transform, because we have applied a Fourier cosine transform. Fourier cosine transform of u x comma. This is Fourier cosine transform u x comma t. But we require u x comma t. Therefore, apply inverse Fourier cosine. But we require u x comma t. Apply inverse Fourier cosine. So by inverse Fourier cosine transform, we have by inverse Fourier cosine transform, we have u x comma t is equal to u x comma t is equal to root of 2 pi pi instead of FC of s, you can use u bar s comma t for the cosine transform. U bar s comma t cos sx ds. Root of 2 pi pi integral 0 to infinity u bar s comma t is here root of 2 pi by a by s square plus a square e power minus s square a square a by s square plus a square e power minus s square a square t cos sx ds. Therefore, we take constants outside here. 2a by pi, 2a by pi cos sx by s square plus a square 4 minus s square a square t ds. This is general idea u of x comma t. If you know particular values of x and t, we substitute, then everything comes in terms of yes only. Yes. Then you can integrate further. Depends upon the function you are getting. So this is the idea you can get. Solution of the problem. U x comma t is equal to a by pi plus 0 to infinity cos x by square plus a square. Okay. I think all of you understand the idea of solving one-dimensional heat equation with the help of infinite Fourier sine transform and infinite Fourier cosine transform. Okay. All of you understand this topic here. Okay. Okay. Yes. Very good. Fine. And then I think all of you submitted your assignment. There's 9 more questions have to submit the assignment. Cynthia, Jocelyn, Kasiraju, Asha, Chantrika, Dinagar, Punna Rahul, not submitted.
Sir, I will submit it today, sir.
Submit today. Why? Why delay?
They are
Right.
tough, sir.
Raiga, Nagamat, Sopa, Siddesh are also not submitted. Tarnish, Tarinish, Vengat Suthi, Yajnanathan. Is these people are here? Punna Rahul is here. And other persons are submitted. Similarly, you have previous 2 assignments. Five persons not submitted. Yajnanathan regularly not submitting assignment. Okay. Is also 5 persons. Venkat Sudip also not submitting. Shopa, Sitesh, Tarnis, these 3 are not submitted. First and third assignment. Bharat Reddy, Dinagar. Watch. Okay, any doubts? Anything? Submit those who are not submitted assignments. Submit today and tomorrow itself. Don't delay submitting the assignments. All the 3 assignments. That marks for assignments, 5 marks will be considered for the assignment here. Therefore, don't take it as easiest manner. You have to submit all the assignments that is given for you. Okay. If you have any doubt, you can ask. That's all this session. You will see some more topics in the next class. We'll see. Thank you. Thank you.